Hello everybody, this is Coach Gear and I'm making your video for compound interest. As you know from the past few days, we did simple interest, which again is very simple and not really a real thing. However, we still have to solve problems like that. Today we're talking about compound interest. So as you see through your notes here, compound interest, when we solve that, it's actually on a yearly basis. Okay, this means that the interest that you're charged or earned, okay? Charged interest is like if you have a loan like for a car or a house or maybe a credit card, or it's earned if you like have money in a savings account. They actually give you a little extra money for putting your money in the bank. Okay? And the way compound interest works is it's added into your account, and then that interest is either charged that you were either charged or that you earned on that account. Actually you earn interest on that also, or you're charged more interest on that extra money. Okay, so it's a little different than simple interest, and it's going to end up being more money in both cases. So since this is happening, the formula that we use to do compound interest is a little different than the one we use for finding simple interest. Okay, so again, simple interest looks like this. I equals PRT, where I was the interest earned, the capital P was the principal or the money, okay, the rate was the percent, and then the T was time in years. Okay, well, we use those same different numbers to find compound interest, except they're in a little bit of a different formula. And you see this A here? This A stands for what's in the account. Again, this one just told us the interest earned. This one is actually telling us the new amount in the account. Okay, we're still using the money, we're still using the rate, and then up here you need to put a little T, and that's not a great T. I'll try to make it a little better. There we go. A little T. Make sure it looks like that, because if not, it kind of looks like a plus sign, which it kind of sort of does. But that means we're going to take the rate, which is the percent, add 1 to it, do that to the power of however many years it is, and then multiply that times the money part. Okay? So when we solve this, it's going to be a lot different. But again, you're going to put this all in the calculator, so you won't have to do any heavy math or anything like that. The calculator is going to do it all for you, but you just got to know how to set it up. Okay, so again, it requires a little more work. We kind of talked about the fact that the numbers you're using are the same. Remember that when you have the rate or percentage, you have to change it to a decimal. Okay, 3% is not the number 3, it's 0.03, and we did that for simple interest, so that's going to remain the same. The T still stands for time in years. And again, the difference is you're solving for A, and that is going to tell you how much is actually in that account or how much you're going to pay back altogether. Okay, so we're going to do an example problem here. So here's the example. You're going to put $6,000 in the bank, earning 3% compounded annually for 8 years. How much will you have in that account after the 8 years? So again, our formula, P times 1 plus R, and again, put your T up here. Okay, and for this one, hopefully you have enough room. I don't know if I left enough, but we'll just put a number there, 6,000. Again, that's the amount of money. The rate, as you can see, is 3%. We have to change that to a decimal, so it's 0.03. And then all of this is to the power of the time, the T, and for this problem, it's 8 years. Okay? Don't have to change that to months, it's just 8. So then we'll just put that in the calculator. And that's all we got to do, and we can do this all at once. So again, 6,000. And as you see, this has parentheses, so use the parenthesis buttons. They're right here on your calculator, right below this COS and TAN. So then 1 plus 0.03, close the parentheses. Now to do power, you can use this sign right here. You just hit that and we'll see what happens. And then hit 8. Okay, see the 8 there? And then when you hit enter, you find out that that account is actually now going to have $7,600.62 in it. So we get an answer of $7,600.62. Now again, that is the new amount in that account. That's what the A stands for, the new amount. Okay? Now, this means that you have earned how much? Okay, again, this means that you have blank now in the account. Well, that's how much you have. You have $7,600.62. But we also want to be able to find out how much you actually just earned. So, well, we can just do this on the calculator too. Again, the $7,600 is how much is in the account. It started with $6,000, so we just subtract that, and that tells us how much you just earned in interest. So you just earned $1,600.62 in interest. And again, we subtracted the principal amount of $6,000 to find that. Okay? So if you can just understand the formula and know where the numbers go, then all you gotta do is put that formula right there in the calculator, just like that, and it'll do all the work for you. Okay, so turn your paper over to the next page. Example 2. Now again, the first one you put money into a savings account and they gave you some money back. Well, for this one, you're taking a loan out. So you decided to get a 5-year loan for $25,000 to buy a car, decent car I would imagine, and after checking your credit you find out that they will offer you an interest rate of 8.5%, which not really important to you, but for a car that's pretty high. How much would you pay in total, okay, in total, over the life of the 5-year loan, and how much interest would you end up paying? Okay, and again, it doesn't say this in here, but this is compounded. You need to write this down because this is something you'll see. Compounded annually. That means every year. Again, that means they charge you interest for every year, and you get that basically is added to the amount you owe, and then they charge interest again. So it adds up a lot quicker. Okay, so again, using our formula, remember you put your T up here. Okay, we would have this formula now, $25,000. Now, 8.5%. Again, your easy rule for changing percents to decimal is 2 times to the left. So that's 0.085. So that goes right here, 0.085. And this is a 5-year loan, so that's to the power of 5. So it should look like that. And I'm sorry that this is, but that's 0.085. And again, we're just going to put this right in the calculator. All right? So we're going to clear up what we had before. Clear, clear. And again, $25,000, open parentheses, 1 plus 0.085, close parentheses, and then to the power, that's the button under clear, and you put a 5 there for the 5-year loan, and that tells you that you're going to end up paying back a total of $37,591.40. I'm going to raise that to 42 cents. So after putting this in the calculator, you get an answer of $37,591.42. Now again, that's how much you're going to pay back all together for that $25,000 loan you took out. This means you would pay back a total of, and again, I know this is redundant, so we're doing it again, but you need to understand that this is the total amount you're going to pay back now. And now we want to find the amount of interest. So what we do is we just subtract the amount of the loan, which was $25,000, and we see that we actually paid $12,591.42 in interest. So that's a lot of money, right? Well, that's what happens when you take out a loan. Okay? So there's your interest amount, $12,591.42. But again, that was a pretty high rate for a car. You probably wouldn't do that for a car. Cars are more like 3 or 4%, which would be a little bit less money. Okay, now the last thing we're going to be doing is moving whatever that is off the paper first. Whatever. We're going to be comparing the difference between simple interest and compound interest. Okay, so here's our example. Mike wants to figure out the difference in how much he would earn in a savings account that earned simple interest and one that earned interest compounded annually. He has $40,000 to put in an account, and he will leave it there for 10 years. The bank tells him they will give him an interest rate of 3.5%. So the first one we want to do is the simple interest. Now, you could kind of do this, I guess, if every year when they told you how much interest you earned, you then took that part out of your bank, but left the, in this case, $40,000 in the bank, and just did that every single year. So that's could possibly happen. So again, this is a capital P. Sorry, I made it a small one, a little bit longer. So he's putting $40,000 in the bank. They're telling him they're going to pay 3.5%. Again, 2 times to the left makes this 0.035. And he's going to put this in the account for 10 years. Okay, so once we have that, again, we just put this right in the calculator. $40,000 times 0.035 times 10 years gives me a total of $14,000. So in 10 years, this account would earn $14,000 extra dollars. And then, if you wanted to say, well, how much is in there altogether at the end? Well, then you would have $54,000 because this is what you put in, this is what you earned. Add those together. That gives you that total. Now, let's find out what the difference would be if he did the other annually compounded interest. Okay, so again, it's the money times 1 plus the rate to the power of t. For this one, again, he put in $40,000. We're going to add 1 plus 0.035 in the calculator, and he's doing this for 10 years. Okay, so make sure you get that written down, and I will start putting that in the calculator since you really don't have to do that. So again, we're going to clear this one out. $40,000. 1, 2, 3, 4. Again, open parentheses, which are right here. 1 plus 0.035, close parentheses, to the power of 10. And when you hit enter this way, you find out that this account would then have $56,423.95 in it. Okay, look at the difference. Okay, this one only earned $14,000 and now has a total of $54,000. This one now has $56,000 in it, so obviously a lot more. And if you wanted to find out how much interest was earned, you just would subtract that $40,000. Okay, so this was the interest earned on this one. Interest earned. Okay, but the actual question is, he wants to figure out the difference in how much you would earn in a savings account, okay, one from the other. So again, we're just going to take this total, which was the compounded amount, subtract the $54,000 from the, if he would have done it the other way, and find out that he would have earned, again, our answer should go right here because this is the answer to the question, $2,423.95 or $2,423.95 difference just by earning annually compounded interest as opposed to simple interest. Okay? Well, there you go. There's your video. Make sure you have this done by whatever day you're supposed to, and we will see you another time.